Okay, we did these first ones way back at like the beginning of the whole year. And I would go back to shoe size is discrete because there's only certain sizes of shoes, but foot size would be continuous. Because you can theoretically have any size foot, right? 9 inches, 9.0001 inches, etc. But you only have size 9, 9.5, etc. shoe. The speed of a race car, then, is continuous because it could be theoretically anything, 59.0004 miles per hour. The number of cups of coffee, it depends on how you measure, but if it just says number of cups, we'd say that's probably discrete. I'm not going to have 1.379 cups of coffee, although technically you could measure it that way. But think of how you display this. It'd probably be like a histogram with just 1, 2, 3, 4, whatever. The number of people that play the Illinois lottery each day, you can't have 1.5 people. You only have certain numbers, so discrete. The weight of an adorable baby rhinoceros is continuous. You could have any weight. The time it takes to complete, time is usually continuous because you can have any amount of to the nearest nanosecond or whatever. The number of math majors at NIU, that's discrete because it's just a count. You can't have a half of math major. And the body temp, continuous. You could have theoretically any body temperature. Okay, this is number 1 in the book, so you could have looked this up in the book. Find the probability distribution. That's just every possibility with the probability of it happening. So tossing a fair coin, and we're counting the number of heads. So you need every possible number of heads. So you could get 0, or 1, or 2, or 3, or 4 heads. And what's the probability that you get 0 heads, 1 head, 2 head, 3 head, 4 head? Okay, how do you do this? You might want to just make a quick tree diagram, or actually probably just list the sample space real quick. There's only 16 options. Okay, and then we just count. How many have 0 heads? There's only one way to do that. So it would be 1 out of not very many. So, or no, 1 out of 16. So this would be 1 out of 16 here. And that would be from that. Okay, how many other ways to get 1 head? That would be these 4 right here. So that would be 4 out of 16. How many other ways to get 2 heads? That would be all 6 of these. So that's 6. 6 out of 16. And then there's 4 out of 16 and 1 out of 16 going backwards. So this is like the 4 out of 16 would be these 4 here that you have 3 heads. And then there's only one way to get all heads. Going back up here. Okay, so there's your probability distribution. Make a histogram and describe what you see. Oh, so describe what you see, that should be socks. So then making a histogram, I just stick the options on bottom. I should label it, but they said number of heads you get is X, so I could just label this as X, or I could label it number of heads, and then these up here are just the probabilities. And so I should have maybe convert those, right, to decimals, and then so this would be here, and then histogram should be connected. So real rough sketch, something like that, where that's 0.4 and that's like 0.1. Okay, so and then I'm supposed to describe what you see. So I really should do socks, but we could just say symmetric, centered at 2. Symmetric, center 2. That means the most common thing you'll get is 2 heads, because that's the center. Spread 4, range is 4. I don't think that's really very relevant, no outliers. So, Okay, and now find the probability of that you get less than x is less than or equal to 3 and interpret the result. So interpreting the result would be something like, there is this chance that you will get 3 or fewer heads when you do X, which is tossing a fair coin 4 times when you do something. Or the probability that you get less than or equal to 3 heads is. So I'm not actually going to write that, but then the probability is there's 2 ways to do it, right? So you could do, this would be the probability that, this would be 1 minus the probability that you get exactly 4 heads, because that's the only one that's not 3, and so it would be 1 minus 0.0625, which is 0.9375, and then this would be my answer. Or I could do, this would be the probability of getting x is 0 plus 1, because this is discrete, so I could just add them all up, plus 2 plus 3. And that's just adding these 4 numbers here, which also equals 0.9375. And again, interpreting the result, you just basically write out in words the p of x less than or equal to 3. And I recommend writing the p x less than or equal to 3 as one of your first steps. Okay, then let's see. If a person rolls doubles when he tosses 2 dice, he wins $5. Otherwise, he wins. Is this game fair? Well, let's maybe make a quick probability distribution. So if he rolls doubles, you win 5. So you have 2 options. You win $5. So you only have 2 options. You get $5 or you lose $1. What are the odds of that happening? And then, is this fair? So how many ways are there to roll doubles? There's 6 ways. You can get 2 1s, 2 2s, 2 3s, 2 4s, 2 5s, 2 6s. So there's 6. So there's 6 doubles out of. There's 36 ways to roll dice. And so the rest are not doubles. So 36 of the time, you're losing $1. So is this game fair? Does the $5 make up for the negative $1? So let's just say you played it 36 times. Theoretically, you'd make $30 and you'd lose $30. So in that sense, maybe it's fair, but a different way to look at this, and what probably happens, right? The cost to play the game is $1. Well, that means this should actually be $4, because you win 5, but you already gave them $1. So basically, we just need to find the expected value. How much do we expect to win? Oh, so expected value of discrete is you just multiply down. So on average, I will make $24, 1/36 of the time. Multiply down, and I will lose $30, or I'll lose, $30, 30/60ths of the time. And then you add across. Let's say you do expected value. Multiply each times its probability, each value times its probability, and add them all up. And this gives me a net loss of negative 6/36. So if I played this game an infinite number of times, if I played this game many, many, many times, on average I will lose 6/36 or 1/6 of $1 every time I play. So we could say, no, it's not fair. They make money, or whatever. So similarly, they sell 100 tickets at $5 a piece. And there's $500 prize, 5 $100 prizes, 10 $50 prizes, and the rest are losing prizes. And there's 100 tickets. Okay, so what are the values you could win? Okay, so let's not do the little mistake I did on the first one on purpose. But here's the different values. You could make $495. You can make $95. You can make $45, or you could just lose $5. So those are all the different values you could get. There's only 1 out of 100 chance you do this. There is, 5 out of 100 chances you do that. There's 10 out of 100 chances you do that. And 1 plus 5 plus 10 is 16. So there's 84 ways that you will just lose your $5. So now if you get your expected value, you just times these all down. times this down, times this down, times this down, and I would just get those all as decimals. Then you'll sum this up, and that will equal this. So here's the decimals. When you add these up, you get $10. So is this fair? Well, there's actually a question with this one. But yeah, I mean, it's not fair, but you should play it, because if you played this raffle over and over, you'd end up making $10. And just look at it, right? They sell 100 tickets at $5 a piece. So whoever's running this raffle is going to take in $500. But they're giving out 500, 500, 500. They're giving out $1,500. So if they're trying to make money off this raffle, they dumb. Okay? If they're trying to give out money, okay, cool. Yeah. But normally the idea here is you make the raffle so overall you net like $1,000, but some people do get some money, so they'll actually play your raffle. So that's how that one works. Okay, and then this last one I'll go through very quickly. So find the probability x equals 2. That's just what's missing out of all of these. So these all should sum to 1 if this is a probability distribution. So I just do 1 minus 0.41, 0.38, 0.08, and 0.02. And that left me with 0.11. So this would equal 0.11. And then probability of less than 2 is 0.41 plus 0.38. All the numbers less than 2. And so, yeah, less than or equal to 2, now it'd just be that one plus the extra 0.11. And then less than or equal to 0.1, that's the same. B and D are the same, right? Less than or equal to 1 would be 0 and 1. Greater than 2, one option, if you know greater than 2 is the opposite of less than or equal to 2, so I could just do 1 minus my answer right here. Or I could add up 3 and 4, and probably 3 or 4 is just another way to say this same one. Since they're independent here, the way these work, I can add an or, you just add the probabilities. Normally you add them and subtract any overlap, but there's no overlap in these. And so, there you go.